So hello everyone, let's derive G. So I'm gonna give you the basics first. So we know what velocity is, right? Velocity is the change in distance, displacement by time, right? Rate of change of displacement.
Yes.
And we also know what acceleration is. Acceleration is the change in velocity by time, the rate of change of velocity.
Yeah.
Now I want you to grab a notebook and a pen, and I want you to combine the formulas, right? I want you to incorporate the velocity into the formula, right? So tell me what you get. I'm gonna give you 2 minutes for that. So you have two formulas, S equals Vt. I'm gonna write it in the chat as well. S equals Vt, and the other formula is A equals V minus U by T. So you can also get V equals U plus AT. So I wanted to use these two formulas and then derive a formula for in terms of distance. The distance should be the subject over there. Okay. You can unmute and ask, by the way. So distance in the terms of whatever you can get. Like you already have distance in terms of velocity and time, but you also have velocity in terms of like initial velocity and acceleration and time, right? So instead of V, just put in the formula, the acceleration formula. Let's see what we get.
Ut plus half at squared. Is that what you're asking?
Can you repeat that?
Ut plus half at squared.
No, that's not what you get.
Is that what you're asking for, though?
No.
What are you asking? What do you want me to do?
Check the chart, bro. There's two formulas. S equals Vt, A equals V minus U by T, right?
Yeah, you wrote them down. What do you want me to do?
I want you to put the V, like I want you to derive the V in terms of acceleration. V equals U plus AT and put it there. Okay, so what do we get? What we get is S equals T U plus AT in brackets, right? So what we get when we do this equals S equals UT plus AT square. I don't see how you people are getting the half in there. Okay, how did you get half AT square, Ashrit? You can unmute, right?
Yellow. Did you ask me that, or
Okay, you answer, Vamsi. How did you get the half in there?
I didn't? I just thought you wanted me to say that.
No, what formula did you get then overall?
You'll get S equals Ut plus at squared.
Do you think it's correct?
Uh, well, in this sense, yeah.
Okay. Uh, I want you to spend the next 1 minute thinking about why it's wrong. It is wrong. I'll tell you that. But why is it wrong? So we just derived the formula, right? S equals ut plus at square. But why is it wrong? Okay. Anyone? Ashrit Ashman?
What's the question?
See, I gave you the formula, right? So in
Mm-hmm.
the chart, you just derived S equals ut plus at square.
Hmm.
I'm telling you it's wrong. But where was the mistake? Like you just saw the derivation.
Give me a minute. I'll check.
I'm gonna share my screen to make it easier for you people. Mhm. So, yeah. Can you see my screen?
Yeah.
Yes.
Okay. So this is what people derive, duty plus 80 square. I'm asking you, why is it wrong?
The V here is average.
Exactly. The V in the formula S equals Vt is average velocity. And this formula V equals U plus AT, it's for final velocity or instantaneous velocity. So there are two types of velocities. One is average velocity and one is instantaneous velocity. Instantaneous velocity is the velocity we have at a specific point, and average velocity is the average of something over a period of time, right?
Hmm.
You had me checking my math when you could have just
Got
told
it.
me it's
Got it.
theory error.
So here's how the derivation should have gone. I'm going to share my screen again. So V equals U plus AT. So S equals average velocity times time, right? So when acceleration is constant, we have this formula. Average velocity equals U plus V by 2, because it's like the mean of the velocities, right?
Yeah, yeah.
So U plus V by
Yeah.
2. So we're gonna substitute the average velocity. So we get S equals U plus V times T by 2. But now this final velocity, this instantaneous velocity can also be written as U plus AT. Can you see my cursor? I'll annotate.
Yeah.
So this part we get from here, and this part we get from here. Make
Oh
sense?
no, we're substituting values. No.
Yeah. So we get 2U over here, but 2U by 2 gives us U, and then we have the T out. So UT, and then we get AT times T. We divide it by 2, we get AT square by 2. So this is how you derive the formula. Make sense?
Yeah.
So now we're going to be
But
using this. Yeah.
nothing.
So we're going to be using this formula and then substituting these values for uh, this specific type of motion in which the initial velocity is zero and the only force acting on the thing is gravity. Does anyone know what we call the motion?
Can you repeat the question once?
Okay, so we are going to be using this formula to incorporate for a motion. Okay, so Vamsi can't unmute. He's having unmute issues. Okay, you can use the chat, Vamsi. Yeah. So okay, the only thing acting on the body is gravity, and the initial velocity is zero. What's it called? Seeing no responses. Gravitational force.
Gravitational force.
No, no, no. That's the force. Okay, it's called free fall motion. You may have heard of it before, I think. Free fall motion. So I'm gonna be sharing my screen again, and then I have a pre-recorded video of how I use the derived formula for free fall motion. Not share my no, just a second. Video. Yeah. Zoom, share screen, share. Can you people see my screen? Okay, it's loading.
Yeah, we can.
You can start the video.
It didn't start for you people yet?
No.
No, it didn't. It didn't.
Oh,
Really laggy.
interesting. Can you people see it now?
Yeah.
I'm gonna play the video, confirm whether you can see it or not.
Okay.
Uh,
you
yeah,
see
yeah,
Yeah.
yeah.
Okay.
Yeah.
Yeah.
Enable voice. Enable voice.
There's
We
no
can't hear
audio.
it.
The
Okay.
audio, yeah.
You must share with volume. There'll be an option. Did you click that?
Yes, sir.
Once you click share, there should be share with audio. Wow. This is a real hole in the script, huh?
Share sound. Yeah, I'm more on. Okay, can you see it now? It's loading. Okay, can you see it now?
Yeah, I can see it.
So, is it working?
Yes.
Yeah, yeah.
Basically, we
I
saw
can hear.
this formula, right? To derive this formula, s equals ut plus half at square.
It stopped again, man.
Did it stop for everyone or only him?
No, for everyone.
It's static.
Okay.
Yeah.
Uh, uh, I'll. There's one more way to do this. Okay, wait, my bad. I'll stop sharing. Give me a couple minutes. An alternative I have. Internet seems to be fine. I think Zoom is lagging. Okay, I need to switch off my virtual background. Virtual background. Okay, can you people see a whiteboard there?
Yeah, we can see. We can see.
Okay. So, so is it visible?
Yeah, you can just put it down. We can see it from there only. Yeah. Yeah.
So basically, you got s equals ut plus half at square, right?
Yeah.
But considering the free fall laws, u is 0 and gravity is g. G is like the only
So
acceleration.
S equals.
See,
So
gravity.
it's t will become 0. That first
Yes.
part will become 0.
Yes, this becomes 0. And because we have the only force acting on it is gravity. So instead of a, we can write small g because that's the acceleration due to gravity, right? Make sense?
Yeah.
So 0t plus half gt square. So 0t means basically 0. So h equals half gt square. Now I want to make g the subject here because we're deriving g.
Okay. So
Yes,
you
initial.
can. Okay. Yeah, got it.
Yes, yes, Ashman. Initial velocity is taken to be 0 because this is like free fall. We have 0 velocity in free fall. It's a law. So we multiply by 2 on both sides. We get t square g or g square gt square equals 2h. And g equals 2h by t square. Right? Make sense?
Yeah, makes sense.
Okay, so now that we have a formula on how to calculate g, how do you think we should go about it? It's 2h by t square.
We can wait. Can you send a formula in the chat once? I'll try.
2h by t square. So it's like we'll be dropping it from a height, right? The height is h, and the time it takes to fall down is t. Okay, I think I sent it to Ashman by mistake. I was supposed to send it to everyone. Okay, Ashman has sent it to everyone. Okay, so how do you think we should go about it? How should we calculate it according to you?
He solved it already.
I did solve it, but now we need to do an experiment, right?
Okay. So
Yeah. How should I do the experiment according to you people?
uh, try to resubstitute the values.
Yes. So we can calculate. We can get the height and get the time, right? If we substitute the values. But here's the catch. Like if we do it IRL, there's too many factors like air resistance, and then there's like I'll take some time to calculate the exact time, right? I mean, when the ball falls down, when the object falls down, I need to take some time to pause it, pause the stopwatch and calculate the time. And then the watch is gonna take some time to like take it in. So how do you think we should balance all of that?
I didn't get you. Can you repeat one?
See, when we do the experiment IRL, there's too many factors such as
Hmm.
uh what do you call that? Friction, energy loss, and we have
Well,
air
they're
gap.
negligible.
Huh?
Some of them are like, to be fair,
Yes.
it
But
depends, right?
then
So you
when
can just not add them.
yeah, but when I'm calculating the specific value of time, because I can't drop the ball from a lot of distance, right? Because I
Yeah.
don't
Wait,
have an
are you trying to calculate the maximum height of the object uh, when you throw it up? Is that
no,
what
I'm
you're
I'm
asking?
trying to calculate G
Uh, uh, I
with the
mean, if
first.
time and yeah, and if time and initial velocity is given, then you can actually calculate g.
No,
G is equal.
we just need height and time. We'll take initial velocity as 0. Okay, that should simplify it, right?
You're asking me why, like, how to make sure that these like air resistance at all don't come into play.
Yes, how do we make it more accurate? Like it should be a realistic solution as well, right?
Yeah.
So
Not
the first thing we can do is we can watch as the ball falls down, and when it falls down, I use a stopwatch and then I pause the timer at that point of time. Okay, that could be one way. But then let's say
that's not really that's not really an accurate way. I'm not going to lie.
yes, because the problems over there would be some problem in the measurement of height and my reflexes. I have good reflexes, but that won't be good enough. And the watch, right? The watch is gonna take some time to work with the input.
It's gonna have to. It's gonna start later, perhaps when before you throw, because you can't really multitask that. And even if you do, there'll be a slight delay either way, so you won't get the exact outcome.
Exactly. However, if we do that, we can get a close enough value. Okay.
Yes. Yeah.
So I'm gonna share my screen again. Just give me a second. There seems to be some issue right now. Okay. Loading. So I did calculate the value of G, and what I did was I calculated somewhat the exact height, right? And then I calculated the time it takes to fall down. The time was it had errors because of my reflexes, but for like the watch input time and output time, I managed that, and it takes like 0.01 seconds, 1 millisecond for input and output. So I subtracted 0.02 seconds to make it better. So I'm gonna share my screen, and I can't do this thing right now, so this video better be visible. Share. Can you people? Okay, it's loading again.
It's loading.
I don't think I shared with sound. Wait, let me share again.
Yeah.
I did share it with sound. Okay, I'll share it again. Optimize for video clip. Can you people see it now?
Yeah, we can.
Okay. Let's hope this works.
Yeah.
Yo.
Start playing with
Is it working?
Wait, continue. We have to see the audio.
The acceleration of gravity. Is it audible?
Yeah, it is audible.
It's like very glitchy and yeah, but I guess it
But
works.
there's a black bar on top of the
Okay, this thing, right? I need to. This thing, I suppose.
yeah.
Um, Acceleration due to gravity. I don't think I can do anything about that. Sorry.
Okay. It's fine.
I can move it, I suppose. Okay. Of Earth. Use the way derived previously, right? This is the same thing. G equals 2h by t square. Now, I'm gonna measure the height from my false ceiling, right? And then we'll drop a ball from there and measure the amount of time it takes to reach the Earth. And then we're gonna plug it in to the formula and then get the value. Okay. So I'm gonna pause the video to get the measuring tape set up and be right back. Hello guys, I'm back, and see my measuring tape is set up. So I got the measuring hook thing over there, and yeah. So let's see how much this measures. So this is the centimeter scale. This is 250 centimeters, going a little bit down. We see this is like, okay, it's exactly 2.6 meters, right? 260 centimeters. It's exactly that. Awesome. We get a round value. So now that we have our height in centimeters, we want to convert it to meters. So 260 centimeters is 2.6 meters. Now the time. I'm gonna pause the video again, get it set up, and be right back. Okay, I have my ball and a watch ready, right? So here's the watch we're gonna be using, and get ready. Standing on my bed, do not tell my mom. I'm taking this risk because science requires sacrifice. Walter level. So we get the ball ready. Hide the shoes.
You can touch your ceiling, it's crazy.
Huh?
Nothing. Why can I say anything?
Use the watch in like 3, 2, 1. Okay, I did not start the timer, guys. I did not start the timer. I'm a moron. Not actually. 3, 2, 1. Okay. So what we get is 0.75 seconds. I'm gonna show it to you guys. Yeah, so here we are with the measurement. 0.77 seconds. We got 0 seconds, approximately 0.75 seconds, same thing. I like getting round values. So let's plug it into the formula. We get G equals 2 times H, 260 centimeters. In meters it would be 2.6 meters, and 0.77 seconds. Let's check the exact value. Let's see. Square, right? We got the square equals to, I'm gonna plug these things into my formula and show you what we got. When I say formula, I mean calculator. I'm gonna plug these things into my calculator. That's what I meant. Yeah, my bad. So we plug it into the formula, equal to 8.77. Right, but I think there was a little error while 8.77 meters per second square. I clicked it like 2 milliseconds ago, but the watch takes like 0.1 second to process that. So if we use 0.75 like we should, that's a closer approximation again, because it's the amount of time the watch takes, right? We don't want to include that in our calculations. It takes like 0.1 second to pause and start it, times 2 by 0.75 seconds. So we are doing 0.75 seconds instead of 0.76 because 1 for starting, 0.1 second for starting, 0.1 second for ending, right? So we got an excess 0.2 seconds that we need to remove because of the watch's inaccuracy. So when we plug this into the formula, we get approximation for the value of G. I'm gonna do that. This thing is 8, by the way.
Yeah, sure.
Right, as you can see, we get 9.24. 9.24 meters per second. Now again, this is not precise because not precise because of my reflex speed and all, or I may have clicked it a little bit before or a little bit later, but I think it's pretty close. The actual value we're supposed to be getting is 9.8, right? 9.72 actually. So we have a small difference of like 0.5 meters per second. It's a lot in terms of physics, but when you're doing an experiment at home without any proper stuff and technologies and instruments, I think it's close enough. 9.24 meters per second, right? So yes, now you know how to derive the value of G. Now you know how to work with the earth. Thank you for watching. Yeah, so that's all. Please tell me the video was visible and audible.
Yeah, it was
It was.
really fun. But there are lots of black screens, but yeah, we got the gist.
Okay, I'll be uploading it separately on YouTube, so I'll give you people the link for that if that helps. So the
Hmm.
point is, when we use the formula, we got the value as 9.244444, and it was because I am a moron and I have interesting reflex speeds. So if I
Hmm.
press it at like exactly when the ball touched the ground, then I think we would have gotten a proper value. But it was close enough because we incorporated for the watch failure, watch error, and luckily the height was exact, so it was like a round value for that.
Hmm.
So it's not that bad if you think about it. So that's all from my side. If anyone has any questions or anything, please put them on the stage. Okay, no questions, I see.
Hmm.
That's it for today then. Thank you for watching and being here.